In today's mathematics lesson, under computation with positive integers, we are going to look at place value in Hindu Arabic numbers. Place value in Hindu Arabic numbers. First, we need to understand that the most commonly used number system today is called decimal system or base 10. Currently, we call it decimal system or base 10. That is the most commonly used system in today. Like the Babylonians, we find that the value of the digit is normally going to determine the value of that one digit. Each position of the digit in the decimal system is going to determine the value of the number. That happened when we were also looking previously in the Babylonian system. However, a digit 0 is going to be used. We are going to have a digit 0, unlike in the other old number system that we have had. Now, generally, the decimal system originated in ancient India about 3000 BC, and it has spread out through Europe and across the countries to over 4,000 years. So it has been used for quite long and spread out into so many countries for the period of about 4,000 years. Now, I want us to look at the following numbers, 0 all the way up to 9 without repeating. So we have these numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, these numbers are called digits. The numbers we have here are called digits. So, looking at these digits, we shall find that at any given point, the value of the position of each digit will determine the value of the number. The position of each digit will depend on the position where we have placed the digit. And here, we want to take an example of the following. Take, for example, 126. 126. There are 3 digits. We want to find out the position of the digit 2. The position of the digit 2. Now, you realize that this is 126, but when we pick only 2, its value will be taken to be 20. The value of the digit position 2 is 20. Now, another number, 3,254. 3,254. This can be broken down in expanded form so that we can get to know the value of each position of each digit at any given point. You'll notice that when we expand this, we shall have the position of 3 as 3 times 1000 plus the position of 2, which is 2 times 100, the position of 5, which is 5 times 10, and finally the position of 4, which is 4 times 1. This side is the expanded form of the basic numeral 3224. Therefore, we need to know the location of each digit in this particular case. How come we are breaking it here into thousands, into hundreds, into tens, and into ones? This can be illustrated as follows. So looking at the first digit, that is the digit 3, it stands for thousands. Digit 2 stands for hundreds. Digit 5 stands at a position of tens, and 4 is ones. So this is what we notice when we try to position the digits. So this is thousands, hundreds, 5 is tens, and 4 is ones. So this is how we break down to come up with the expanded form of the basic numeral of 3254. Now, let us now look at the symbols that are used to compare numbers. I want to look at the symbols. Symbols used to compare numbers. The first symbol we have is this. This symbol is called equals to. It's called equals to, which can be illustrated when we say 1 plus 3 is equals to 4. It is very true that 1 plus 3 is 4. Therefore, this sign here is a symbol that is used to compare numbers. Another one is this symbol. The symbol that we have here stands for is not equal to. Is not equal to. Is not equal to. And we can simply illustrate this by saying that 1 plus 3 is not equal to 5. 1 plus 3 is not equal to 5. Then we have another sign. This one, we write it like this. The sign that we have there is a sign that means is greater than. It stands for greater than. For example, we can say that 5 is greater than 5 is greater than 4. 5 is greater than 4. That is very true. 5 is a digit that is greater than 4. So we use the sign instead of writing the whole statement. Another sign we use is this, which stands for is greater than or equal. We can agree by saying that is greater than or equal. We can agree by saying 5 is greater than or equal to 4. So we know very well 5 is not equal to 4, but it is greater than 4. But it can also be used to bring the relationship where 5 is always either greater than 4 or equals to 4. Next symbol is this. The symbol that we have here stands for less than. Stands for is less than. We can say that 4 is less than 5. That's true. 4 is less than 5. We don't need to use the whole statement. We only use the symbol. Other signs have less than or equal to. Is less than or equal to. You can say that 4 is less than or equal to 5, but it's not greater than 5. Another sign that we have is this, or sometimes we use this. The sign that we have there means is approximately. Is approximately equals to. Is approximately equal to. For this case, we can say that 4.02 is approximately equal to 4. So 4.02 is not exactly 4. But it is approximately or equal to 4. So those are mostly the signs that are commonly used when we are comparing the numbers. Now, let us look at some examples that we have. Write down the value of the digit. Write down the value of the digit 4 in these numbers. And the numbers are as follows. A is 437. 437. Digit 4 is underlined. So write down the value of the digit 4 in these numbers. 437. Solution here. You realize that from our initial part of identifying the position or the location of the digit, you'll realize that this stands for ones, this stands for tens, this one stands for hundreds. Therefore, you'll notice that 4 is in the position of 100. Therefore, the value of the digit 4 is 4 times 100, which is 400. The value of the digit 4 is 4 times 100, which is 400. We can find out the other values. If it was 3 here, the value of 3 would be 3 times 10, which is 30. And for 7, it would have been 7 times 1, which is 7. That one would have been the value of the position of the digit 3 and digit 7 if we were to find their values in the location of the number 434. Let us look at another number. This one is 543,910. We are still interested in the value of the digit 4. So looking at the position of 4, we again identify what position does it lie. You'll find that this one is for ones, this one is for tens, this one is for hundreds, this one is for thousands, this one is for 10,000, this one is for 100,000. That is the position of the digits with their values. Our interest is the digit 4. The digit 4 is where we have our interest, and you will find that the 4 will be given as 4 times its position, which is 10,000, which gives us 40,000. So the position of the digit 4 is 40,000. However, for other digits, if we were to find for other digits, for 5, it would be 5 times 100,000, which gives us 500,000. For 3, it would be 3 times 1,000, which gives us 3,000. For 9, it would be 9 times 100. For 1, it would be 1 times 10, which is 10. And we have a 0, which should be a 0 times 1, which is just a 0. So this would be the values of the other digits with their respective values. Second question, write 517 in expanded form. Write 517 in expanded form. Our solution, we shall identify the position and its values. As we have noticed, this is ones, this is tens, this is hundreds. So to write it in expanded form, it will mean that 517 is the same as 5 times, this is hundreds, plus 1 times tens, plus 7 times 1. That is the expanded form of the basic numeral 517. So you need to write each digit separately and multiply by approximate power of 10. So 100 is the same as 10 raised to the power of 2. 10 is the same as 10 raised to the power of 1. And 1 is the same as 10 raised to the power of 0. Why we say that is because a number 10 raised to the power 0 is 1. any number like a raised to 0 is always 1. A number raised to 0 always gives us 1. That's why we have 7 times 1. Let us now look at large numbers and expanded form. Sometimes we have very large numbers. We've only been dealing with numbers less than 100,000. We can have more numbers with a million, a trillion, and so on. So these numbers can be well written in expanded form in what we call index notation. Index notation. For example here, if we want to represent 50 million, we shall ask ourselves the position of 5. You realize that the position of 5 is at 10 million. So to break this, we shall have it, expanded form will be 5 times 10 million. 5 times 10 million. If that is the case, then we simplify this by writing 10 million in index notation. So you'll find that this one will be 5 times 10 raised to the power of 7. These are 7 zeros. So raised to the power of 7. So what we have here, this one here, is what I'm calling the index notation. So we can simply write any large number using a whole value, and the zeros will be replaced by the 10 raised to the power of the number of zeros that we have. So index notation will give us the whole number multiplied by 10 raised to a power. Another number is 3. Let's take, for example, 3,200. 3,200, to change into index notation, we shall concentrate and say that the whole numbers remain. So we have 32. But you realize that by the time we reach at 2, we are at hundreds, which means that 2 times 100 is still the same as 300. But we need to change this one into index notation. So it will be 32 multiplied by 10 raised to the power of 2. Now, all the 0 digits are written down as multiples, are written down, then multiplied by power of 10. We only need to count. For this one, there is 1, 2. There are 2 zeros. So those 2 zeros will be the one to determine the number that will be the power of 10. For this case here, the zeros were 7, therefore the 10 would be raised to the power of 7. Let us look at one more example on index notation. And here, we want to look at 370,000. As said earlier on, we take all the zeros, count them. That is what is going to give us the power of 10, but the whole number remains. So 370,000, we shall take up to 37 times, that 7 is at the position of 10,000. Changing it into index notation, it will be 37 times 10 raised to the power of 4. So this is the index notation of the basic numeral 370,000. We can also try to approach this problem the other way around by converting the index notation into basic numeral. So question, write the basic numeral . 4. Write the basic numeral for 381 times 10 raised to power 2. So this, you will find that it will now mean that we expand this. So it will be 381 times 10 raised to power 2 is the same as times 100. When you multiply this through, you'll find that it is 38100. So it is 38,000. 38,100. This one gives us the index notation of 381 multiplied by 10 raised to the power of 2. Let us also convert 7,204 multiplied by 10 raised to power 3. This one is expanded form, the index notation of this numeral. We want to find the basic numeral, so it will mean that we take the whole number that we have, 7204 multiplied by 10 raised to power 3, which is 1,000. And then we expand it up and simplify. You find that it will 7,204,123. The value of our basic numeral will be 7,204,000. So we have been able to change the index notation of this 7,204 times 10 power 3 to 7,204,000. So this is what we call the basic numeral, while this one here is the index notation. So you should notice that you can use index notation in any other form. So at your own time, research and find out about the following numbers. Now, looking at subtraction, we find that 4 minus 3 is not the same as 3 minus 4. So the order of digits while subtracting is very important. We cannot interchange. At the same time, we also, if we decide to group them, again, we shall find that it's not true when we say A minus B minus C. This is not the same as A minus B minus C. So we cannot use that while subtracting. So looking, for example, and we shall demonstrate using a number line, 7 minus 2. 7 minus 2. This is supposed to be 5. To illustrate that, we shall look at where the 7 is. While subtracting, we shall be moving to the left-hand side of the number line. What we have here, I'm calling it the number line. So the first step, that is minus 1, and then second time minus 2. So we have moved 2 steps to the left, and you have stopped at 5. That's why you are saying 7 minus 2 is equal to 5. So while subtracting, we can illustrate that using the number line. So generally, in subtraction and addition, we can handle it using many various ways. And this time now, I want us to look at the mental addition and subtraction of numbers. Mental addition and subtraction of numbers. We have 4 areas that we can use to solve this. The first one is what we call partitioning. Or we also call it grouping digits. grouping digits in the same position. Take, for example, 171 plus 23. 171 plus 23. We want to group digits in the same position together as we will handle this. So you'll find that when we group this, we have the position of 1, which is 100. 7 is 70. That is what we have for groups. And then you'll notice that here, the group that we have here is 20. Then you'll notice that when we took 100 and then 70, we left out 1. So there is a 1. And when we took 20, we left out a 3. So there is a 3. So I want to put this one in bracket. And then I also put this one in bracket. When we say we are grouping digits of the same position, I want you to look at this. 70, as we said earlier, for all this one is for ones, this one is for tens, and this one is for hundreds. Similarly, 3 stands for ones, 2 stands for tens. Look at this. 100, we only have one group of a digit that falls in the category of hundreds, that is 1. That's why we have 100 here. It is alone. Then the second group we have is a group of tens. At tens, we have 7. At tens, we have 2. That's why we've taken 70 and 20, because these two, both of them, are in the same position of tens. And the last group is 1 and 3, where 1 and 3 fall in the category of position of letters or digits value ones. So we group them that way, and then we simply simplify them. You'll find this one gives us 100 plus 90 plus 4, which is 194. 194. So it is very easy to add numbers as long as you know how to group them according to their positions. That is how we normally add the numbers. Let us look at another example related to positioning or grouping digits in the same position. Let us take 937 plus 11. So this, again, the solution, we are going to use grouping. So we ask ourselves, how many groups are there of 100s? 11 does not have 100, but 937 has got 100 of 900. So that's the first group, plus. How many groups are there of tens? You'll find that for tens, we have a 3 and we have a 1. So it will be 30 plus 10. We group it together. How many groups of ones? We have a 7 and a 1. So it will be plus a 7 plus 1. So we have been able to group these digits to ones, tens, and hundreds. So when we add these together, you'll find this is 900 plus 40 plus 8, which gives us 948. 948. So we can use positioning or grouping of digits in the same position to add numbers. Second method of mental addition and subtraction is what we call compensating. Compensating or making a 10, 100, etc. We make a 10, 100, or etc. and adjusting. Or compensating. And adjusting or compensating by adding or subtracting. So if we are looking at compensating and you're saying this is a whereby we make either a group of tens, hundreds, thousands, and so on, and adjusting or compensating by adding or subtracting. Let us look at the example below. 46 plus 9. 46 plus 9. So we want to add 46 to 9. We need to adjust. So let us take 46. But for 9, we round it off to any of these, 10s, 100s, and so on. So for the one which is nearer to this is 10. But I'll ask yourself, how did we get this 10 related to 9? We find that we took 9 and added 1. So we should be able to subtract a 1 to go back to the original value. And when you do that, you'll find that 46 plus 10, this one gives us 56. Then we minus 1, you get 55. Therefore, you can say that 46 plus 9 is equals to 55. Or we can break it and say it is the same as 46 plus 10 minus 1, where 10 minus 1 is the same as 9. This adjusting, where we are either adding, for our case we are subtracting because we adjusted it to 10, is what we call compensating. Let us look at another example where we are going to use compensating again. Have 19 plus 76. 19 plus 76. 19 is there. We adjust 76. It's nearest, we make it to a 10, it will give us 80. And we realize to get 80, we added 4. So we must remove 4 from our answer. 19 plus 76 is 19 plus 80 minus 4. This one will give us 99, and then we minus 4. So when you subtract that, you find that your answer becomes 95. So you can simply say that when you're adding 19 plus 76 is 95 by either compensating by rounding off, getting that 76 is closer to 80, we have 80 and then we subtract 4, then we come to 99 minus 4, which is 95. That is the value of 19 minus 76. The other method that we have of either adding or subtracting numbers is what we call doubling or halving. Doubling or halving. That is making a double or half. Making a double or half and then adjusting. with addition or subtraction. Doubling or halving. This is making a double or half and then adjusting with addition or subtraction. Let us look at an example where this method is commonly used. Take, for example, 75 plus 78. 75 plus 78. Now, this one, the method we want to apply is doubling. So this one will be 75. Now you realize that this 78 is almost close to 75. So we shall take 75. But then there is something we've removed. What we removed, we bring it back. From 78 to get 75, we removed 3. So we should bring that 3 back. That's what we have. So you find that 75 and 75 has been doubled. So if we do that, you find that 75 plus 75 is 150, then add 3. Then the solution for this particular case is 153. That is our answer when we are using that particular method. Another example, 124 minus 61. minus 61. These are two numerals, 124 minus 61. We need to subtract these two. And in this case, we are going to use doubling. So, or if we don't double, you use halving. You'll find that 124 minus 61 is the same as follows. This will be 124. You realize that we need to make this next digit to be a half of the first. Then it means that we need to increase something, because a half of 124 is 62. So we need to say that what we are subtracting is 62. But to get this 62, what happened? We simply had to add something on this to make it 62. So for this case, we need to bring it back. It has to remain. So because 62 is a half of 124, then it's not easy to subtract here. It's just 124 minus 62, which is 62. But there was 1 which was added, so you bring it back, and then you get your answer as 63. This method is called doubling or halving. We have simply made this time a half of the first digit and then adjusted by either adding or subtracting. So it is always good that a good learner, good student should be able to use any suggested strategy, either compensating, doubling, or partitioning, to be able to solve a problem. A good student should be able to apply any of the strategies to handle problems. Now, let us look at a few problems. Here, the question reads, use the suggested strategy use the suggested strategy to mentally work out the answer. And the first one we are having is 132 plus 156. The strategy to be used here is partitioning. So this is the question, this is the strategy. Solution. So as we said earlier on, partitioning involves breaking this into positions or groups of the same value. So in this case, we have to group together the ones for hundreds, the ones for tens, the ones for ones. So you'll find that taking 132, if we break this, it is 100, that is the position of 1, plus 30, that is the position of 3, and plus 2, that's the position of 2. And then 156, the position of 1 is 100, the position of 5 is 10, so this gives us 50. The position of 6 is 1, so which gives us 6. We are adding. So you'll find that this one gives us 200 plus this is 80 plus this is 8. So you'll notice that we have grouped them, we have been able to add them. Now bringing them together, you find that our answer is 288. So you have been able to add 132 plus 156 using partitioning, and we've been able to get our answer as 288. Still on the same question, we handle a different question, but not using partitioning this time, we use a different method. (25 plus 19), and we are going to use compensating. (25 plus 19), we are going to use compensating. Now, the first numeral is 25. This is for our solution. Plus 19, we round it off or make it closer to a number with a 0, which is 20. You'll find that 25 plus 20, we have added 1 to make it 20, so we shall to subtract that 1. That simply gives us 25 plus 20, which is 45 minus 1, and then we find our answer as 44. Now, compensating means trying to round off the second digit to the nearest what we have, and that is 20 for this case, which means we added 1 to 19 to get 20. That's why we have to subtract 1 as we look for our answer, and our answer is 44. We can also use compensating the subtraction. Let us subtract this. 56 minus 18. 56 minus 18. 56 minus 18 using compensating. And our solution, we find that here we shall have 56 minus 18 is equal to 56 minus 18 is closer to 20, so we shall give in 20. Now take note that what we've done to get 20 is we have added 2. So we have added 2 to get 20, and therefore we should mind about that 2 by bringing it back. So we shall add 2 there. So this one now is easier. We find this one gives us 36 plus 2, which is simply going to give us 38. So using compensating, we are able to find 56 minus 18 as 38. That is what we have. The last method of doubling or halving, let us work on 35 plus 36. And we want to use doubling or halving. For our solution, we find that 35 plus 36 will be the same as 35. Now this one we are going to use doubling, so we shall look for a number that is closer to this, that is 35 again. But to get 35 there is something missing, so we'll bring it back, which is a 1. So we have 35, 35 and 1 we are adding. Now this is doubling, so we shall have double the 35, which is 70, then plus 1. This gives us 71 as our answer. So we are able to double and then adjust it by adding 1 to get our 71. So we can simply use those three strategies to solve problem of addition and problems of subtraction at any given time. So it doesn't matter whatever the question is given, as long as it's addition or subtraction. Now, as we wind up our class, work out this exercise. Write 3 words that mean A, addition, and then B, subtraction. We shall go as we handle each at the same time. When we introduced our topic, we looked at the process at addition as simply the process of finding the total value of 2 or more numbers, and to say other words that can be used to mean addition are words like sum, add, and we have 3. We have sum, then we have add, and then we have the third one, we call it a plus. So these are the 3 words which means addition. Subtraction, we also have 3 words which are minus, take away, and subtract. Those are the 3 words that are used for each case in that particular case. 2, give the result of each of the following. Give the result for each of the following computations. And number 1 is 36, take away 15. And number 2 is 128 and 12. So those are the 2 problems. We shall start with the first one. Take note, take away is a word that is used to mean subtraction. So when they say 36 take away 15, this is the same as 36 minus 15. And then from there, you start using any method that you're comfortable with to subtract this. And you realize if you have to use any of the methods that you want to use to subtract, you'll find that you can simply use either compensation, you can use partitioning, and so on. So for this particular case, we shall simply have it as follows by breaking it up. This one, you can bring it to 35 minus 15. You realize that we have removed 1 to get that 5, so we bring that 1 back by adding. So when you subtract this one here is easier, which gives us 20, and then you bring in 1, which gives us 21. So you have been able to subtract 36, take away 15 is 36 minus 15, which is actually 21. For the second part, we have been told 128 add 12. This is the same as 128 plus 12. To work out this again, you can use any of the methods. I want to use partitioning, which will mean this is 100 plus we have 20 plus 10. Put that one in bracket, plus 8 plus 2. Put that one also in bracket. When you work out that, you'll find this one is 100 plus 30 plus 10. This one is going to give us 140. So that is how we work out problems when dealing with numbers on adding of and subtracting of positive integers. That is the end of our lesson. In our next class, we shall look at further algebra on algorithm for adding and subtracting. Thank you.